Comprehensive explanation of Kubernetes Load Balancer service workflow. The Kubernetes Load Balancer service is used to expose applications externally, allowing external clients to access services running in a Kubernetes cluster. This workflow explains how a request travels from an external client to a backend pod through a load balancer service and how the response returns. Step-by-step workflow. 1. External client sends request. The external client sends a request to the load balancer's external IP. This IP is assigned by the cloud provider, e.g. AWS, GCP, Azure, and acts as the entry point for all external traffic directed to the Kubernetes application. 2. Load balancer routes request to a Kubernetes node. The cloud provider's load balancer receives the request and determines which Kubernetes node should handle the traffic. The load balancer uses algorithms like round robin or least connections to distribute requests evenly among the nodes. 3. Node forwards request to the load balancer service. Once the request reaches the selected Kubernetes node, it is forwarded to the load balancer service running on that node. This is possible because the NodePort service created by the load balancer exposes the service on each Kubernetes node at a specific port range, 3000 to 32767. 4. Load balancer service identifies backend pods. The load balancer service determines which backend pods can process the request using endpoint objects. These endpoint objects contain the list of healthy pods associated with the service, ensuring that only ready and available pods are selected. 5. Pod selection and request forwarding. The load balancer service selects one of the backend pods based on a load balancing algorithm, e.g. round robin or random. If pod 1 is selected, the request is forwarded to pod 1. If pod 2 is selected, the request is forwarded to pod 2. The selected pod processes the request and prepares a response. 6. Response routing through the cluster. After processing the request, the selected pod sends its response back to the load balancer service. The load balancer service routes the response to the node, which forwards it to the external load balancer. Finally, the external load balancer sends the response to the original client, completing the request-response cycle. Key components in the workflow. 1. External client, the source of the request, such as a user's browser or an external application. 2. Cloud load balancer, a cloud provider managed component that acts as an entry point for external traffic, routing requests to Kubernetes nodes. 3. Kubernetes node, a physical or virtual machine running Kubernetes that hosts pods and services. The node receives requests from the load balancer. 4. Load balancer service, a Kubernetes service that maps external requests to backend pods, managing traffic distribution and ensuring reliability. 5. Backend pods, the application instances running inside the cluster that process client requests and generate responses. Key features of load balancer service. 1. External accessibility, provides a public-facing IP address, making Kubernetes services accessible to external clients. 2. Dynamic load balancing, distributes incoming traffic across nodes and pods to prevent overload and ensure high availability. 3. Health checks, uses endpoint objects to ensure only healthy pods receive traffic. 4. High scalability, supports seamless scaling by automatically routing traffic to newly created pods. 5. Reliability, ensures that requests are routed to functional pods, even if some nodes or pods are unavailable. Conclusion. The Kubernetes Load Balancer service simplifies exposing applications to the external world by seamlessly managing traffic distribution across nodes and pods. It provides scalability, reliability, and efficient traffic routing, making it ideal for production-grade applications requiring public accessibility. By understanding this workflow, you can see how Kubernetes orchestrates seamless communication between external clients and internal workloads.